Hey, and welcome to this short tutorial breaking down a little bit how the wild robot rig works and how it's created. And in this video I'm gonna shortly show how I use geometry nodes to make the rig work as it does. So combining traditional rigging with geometry nodes to create something that works beautifully and a bit differently than maybe your average rig. The short animation I made at the start was done very quickly. I am no professional animator, but I tried to showcase kind of how it can be used, and you can apply this to any other rig that you have. But let's dive into Blender and check out how this works, and then let's build the system from scratch. So here we are in Blender. This is a quick little image I made a little pose for the wild robot, and just to show quickly how it is working. So this is the rig, the completed rig. It looks to the average animator very normal, I would say. There are the controls just like any other character rig, but the big difference here is the arms specifically. This same technique could be applied to the legs also. It is not in this rig made in that way, but for what I needed this character to do, the arms was all that I needed. So I only made it work for the arms. But like I said, you can apply this to anything and maybe even come up with some new ideas using this method. But essentially what we have here is a normal FK rig, and that works just like any other rig like this, just all completely normal, and the hand also moves around. And then we have this IK controller, and if I move it over here like this, and I have a custom property that moves it from IK to FK, or FK to IK actually, that should be the other way around. Anyway, so when I slide this over, you will see that the IK will now go to the arm, and as you can see, it stretches the arm in a way. And the problem I was having is that if I were to just use stretchy bones, which is a technique, a traditional technique that's used quite often for stuff like this, it would actually scale the geometry, which I didn't want. I wanted it to extend, keeping these rings the same size and just spacing out evenly. So that's why the geometry nodes approach was created. And then what we have is this like elbow controller that allows me to define where it bends and in what direction the arm is going. So you could have it, this is just like the normal straight, and then you can bend it anyway. So you can have some fun animations with that. And that's the same kind of how I pose this arm here, is that I place this just to move it around. And then if I were to just go back to IK, it would to FK, it would just look like this. So what is actually happening here? If I look at the arm is a curve object. It could be a mesh, but I made it as a curve for some reason. But I will explain how to do it both ways. But it has a couple modifiers. The geometry nodes is kind of the thing that makes all this work. So if I turn this off, you will see nothing, because it is shouldn't be invisible, I must say. It should actually be somewhere. If I just, oh, it's over here, I see. But it is just a curve with 3 points like this. That's all it is, and everything else happens under the hood here in geometry nodes. And this is very simple. We'll make a little bit more complex system for in this tutorial, but I hope you learned some cool tricks from this that you can apply to other things using geometry nodes, but this is for breaking down this arm rig. So let's hop into a new file and begin from zero. So what we're gonna need is a curve or a mesh. Both work. I am gonna do it with a curve once again. Actually, I'm gonna do it this time with a mesh. You could do this with a curve as well. So we're gonna add a plane and we're just gonna scale it on the x-axis to 0 and then select all and merge by distance. So we just have these two vertices like this. And then we're gonna add one more in the middle. I will just hide the cursor so we can see. So we have one vertex here, one vertex here, and one vertex here. And what we're first gonna do immediately, let's just call this arm, is create 3 hook objects, because we're gonna need those for the animation. So if you press F3, you will get the search bar and you can type hook and hook to new object while selecting one of the vertices like that. And then if I click the middle one and I hold down shift and press R, it will do the same operation for the elbow, and then for the wrist we do the same. So shift R and it has done it for all of them. I will quickly name these. I'm gonna change the type to sphere on them and then scale them down. Just a quick tip, if you didn't know this already, if you do have selected objects with the same properties across them, that could be modifiers or just their general properties. If you hold Alt, well, if I would just do this, it won't happen anything, but if I hold Alt, it will do it to all of them. And Alt Enter will apply the same menu item or the same value to all of them. So now we have this, and it will automatically create the modifiers for the hooks, and we can leave all that as default. So I'm going to close that. So now when I move this, it will move the vertex like so, and I will move this now so we can see what's going on. And let's just hide these empty, so we just have this. And now we're gonna open up a Geometry Nodes window. You could use the Geometry Nodes workspace. I prefer to do it this way because that's how I'm used to do it. But firstly, we'll add a new Geometry Nodes node tree here. And I'm gonna call it arm. And we're gonna create some space here because we're gonna need some space. So the first thing we want to do is smooth out this line because we want the arm to be sort of flowy and nice. If you would have used a curve, you would first put in a curve to mesh node. So you plug in the curve and just get out the mesh from that. And important then in the curve settings, if I just quickly, that you would take this resolution preview and this resolution value to 1 so that it's just completely, it doesn't bend at all. That was like the big thing that I noticed when I was doing this the first time. So with a mesh it doesn't matter because it will only be a straight line and a straight line. The first thing we're gonna do is get a subdivision surface node here, and this will determine the smoothness of the arm. I'm gonna leave it now for on 3, and then we're gonna turn this into a curve. So mesh to curve, like so. So now it's a curve object, and the reason why we're doing this is that we want to create the rings of the arm along this path, and curves will have attributes that we can use, place them, and rotate them correctly, which we can't do with just a mesh. So to get something instanced here, we're gonna actually want to model something. So I'm gonna make a new collection and make a new object, which is a cylinder. Let's make it, doesn't have to be super high res, 0.1, sure, 0.25, something like that. That looks a bit big. Let's make it half the size, because we can scale that. So 0.075, like that. I'm gonna get these faces and inset them a bit and delete them and give it a nice little bevel. You could do this procedurally as well, but beveling in geometry nodes is still not the most convenient thing to do. So I choose to do it this way. And we're gonna add some UVs to this because we need, you might need to map some image textures to them, so it's good to have UVs for that. And that looks horrible, but if you don't have this add-on, get it. It's the best add-on. It has a bunch of bugs because I don't even know if this is the most recent version of this add-on, but it still works and I still love it and I don't care about the bugs. So what I'm gonna do to grid by shape, and you'll see an error if I just go in and out. You will see all is fine, and I want to put this constraint to image bound just like that. And if I go into the shader and add an image texture, call it grid, and we're gonna put in the color grid like so, and put here in display properties texture, you will see that now there's an image texture very well mapped onto this object. And the reason why I'm showing this is because I'm gonna show you a little trick using geometry nodes to actually then will modify these UVs to make every single piece unique in the case that you may use some image textures. Now go back to the arm, to geometry nodes. So we want to place these rings along the arm. And how do we do that? It's super simple. We add a node called instance on points, and you will notice everything disappears because we haven't plugged in an instance here. And what we can do is we can take this ring and just drag it in here like so, and hide that again. And now when I take this geometry and put it into the instance, you'll see, ta-da, we have a bunch of rings. But what you're noticing is that they're all in the same orientation. They're not conforming to the shape of the arm, and that's why we have this curve, because we can use an attribute that exists on curves to rotate this correctly, and that's called the curve tangent. So what the curve tangent is, if you don't know, it is the direction that the curve is pointing. So you have the normal, which is if you have the curve, actually I can, if I have a curve like this, so the normal will be from here to here, like this, 90 degrees from the curve. So this is the normal. You could use this, but what I've noticed also using this value, that it might point in different directions in different places, and so it might actually rotate along, because technically the normal of the curve is all of the directions out from it. It would be just 90 degrees. from this, but it can point in any direction. So it could go up to the left or to the right, but it's like that. But the curve tangent, if I show it like this, is gonna point where the curve is pointing. So it will be like this, and then like this, and then like this, and like this, whilst the normal would be pointing like this. So how do we get this? If I just plug this into the rotation, you will see that it just does something crazy. So what we need is to modify this value somehow. And there is a simple node that will do it for us. It is called align rotation to vector. So I can take this vector, put it in here, and then take this rotation value and put it in here. And now you can see everything is correct. So what's happening here, it's taking this tangent and aligning the axis that we choose in that direction. And because the cylinder is pointing in the z-axis up like this, z-axis is the correct. If I put y, it will be in the y direction, and if I put x, it's in the x direction. You can see there's a slight tilt to it for some reason. But z is the correct value for us. But now there's one kind of issue with this current setup, is that if we want to make this smoother, you'll see that we're increasing the amount of rings along the curve, and if we want to make it sharper, it's decreasing. So we need to make this value not affect how many rings we have, because we want to have consistent rings along the entire curve. And that we can do by using a resample curve, like so. So if I put this in between here, you can set this to anything, but count is perfect for us, which means I can determine exactly how many rings there are on this curve. So I can increase the smoothness or make it sharper, and the count will stay the same all the time. And if I remember correctly, counting the rings on the wild robot, it was 15. I may be wrong, but we're gonna use 15 for now. And one other thing, if we look at an image of the wild robot, you will see that the arm is actually getting wider along the way. It's not the same size all the way, it gets wider. So we're gonna actually do that also, which is very simple in geometry nodes, and that also is why we use the curve, because the curve we have here, there's a parameter. If we use a node called spline parameter, you can see the factor, and the factor is a value from 0 to 1 along the entire curve. And if we were to move this, the value will stay consistent all the way. So if I just take this, it will always be 1. It will always be 1 at one end and 0 at the other end. So using this value, we can scale the points, the rings, to be bigger along the way. So how do we do this? Let's clean this up a bit here. So for the scale, we're going to use a combine XYZ. Set this off 1. So what I want to do in this case is I want to scale them just on the X and Y axis. I don't want to scale them bigger this way, just like this. And we're going to take this factor value and put it into a map range. And if I plug it in here and here, you will see now that they are actually growing. They're too small here and maybe too small on this end. So what we're gonna do is just find a scale that's good. So let's keep it at 1 here, And then at the other end, let's make it bigger. Maybe 1.5 is decent. And looking at it, I'm just gonna make them a bit longer overall. 1.35, like so. So now we have this kind of growing effect, 1.6. And tweak this value to your liking if you're modeling this same thing. And as shown before, if I grab this, the scale will be consistent and the amount will be consistent. So you can compress the arm and make it longer. And that's working beautifully. All right. So now we have that, but we have this kind of gap along the way. And we want to fill that in with mesh. And to do that, we're going to go back here into the curve to mesh. We're going to take this mesh to curve and go curve to mesh. Like so. And in the curve profile, we're going to use a curve circle. And if we now look at that, you will see a cylinder. It's huge, so we can scale it down using the scale value here. And if we now join these two together, you will see we have something in between, but the scale is wrong. So let's tweak that value first to something that's good. We want it to just about clip through here. But then you're noticing, oh no, it's too big here. So how do we do this? We want to scale it so that it's smaller at this end and bigger at this end. And that again is incredibly simple. And you already have learned how to do this in this tutorial. And it's using the factor. So we're going to just take these two nodes and plug this into the scale. It's of course too big first, so we're gonna scale it down to, what was it, 0.055. 0.05. Yeah, 0.055. And then scale this value also to 0.055. And if we go into here and look, we can just scale this down until eyeballing it until it's good. So 0.325, like this. So now it's expanding at the same, not the same rate, but at a similar rate to always have this contact in between here. So that's perfect. Let's clean this up once again. So now we have the kind of arm setup and everything works perfectly. But before we move on to the actual armature, you remember I was saying about the UV coordinates. So what you're now noticing is that all of these rings have the same UV coordinates because it's just a duplicate of each object. So we want to actually take these coordinates and for each element sort of just move them slightly so that each one will have a different section of UV space. And this is also very simple. So what we're going to do is take these instances and we're going to need to realize them. This just means that it's taking these are now instances, so they're copies that share all data with each other. But we want to make them unique. So we're going to realize them. And then we want to take the UV map and transform them. So if we go into named attribute and go in here, there should be a face corner attribute called UV map. And if we view this, you'll see a UV map on the object. So what do? We're gonna store named attribute. We're gonna store a 2D vector in face corner and call it UV map. You will see, oh no, it's gone. Well, that's because now it's just 0, 0, 0. If I plug this attribute in here, it will be the same. So now we can take this and modify it and then overwrite the old one to create the UV maps for this. And very simple, vector math like this. If I just move it on the y value, you will see that it's moving on the y value, x value, it will move on the x value. Let's combine x, y, z, and now we need just some value for each. And how do we do that? Well, we can use something called the index. But we can't use the index of these objects because the index will be different for each vertex on the mesh. So we're gonna actually use the index of the points that they're instanced on. And to get that to work, we're gonna need a node called capture attribute before the instance on points. And into here we can plug anything that exists on this object type, and in this case we're gonna want the index like so. And if we plug this in here, you will see that now there's an index here. So if I view this with the index, you will see that it's growing. It looks like it's black and white, but it's 0, 1, 2, 3, 4, 5 and forward. And if I now plug this into the x value, it will move each one by a value of 1, which in UV space 1 is just repeating exactly. So we just want to modify this slightly, and we can do that using a math node. So if I go here and set this to multiply, and multiply it by something that some value 0.1, so now each one is slightly different, and we can actually do a different value like 0.333 on the y-axis. So now none of them are gonna be identical, so each one has now unique UVs, but the object underneath is still, well, it doesn't have even a material yet, so we're gonna need to add a material to it, and that we will do with a set material node. And we're just gonna set the same material, and you will notice immediately that there are no UV maps on this, so it doesn't know how to map this texture onto it. And it's very simple to unwrap in geometry nodes. It's very hard to make it good, but we're gonna do it in a way that we used to do UV maps before UV unwrapping was a thing in geometry nodes, because this mesh is gonna expand and shrink. So UV unwrapping it is not gonna work, because every time it grows, it will UV unwrap it again, and the UVs will actually be moving. And we don't want that, because that can actually cause some problems in animation. So what we need to do is define the x and y axis of the mesh, and we can use this spline parameter, the factor, to actually do this. So before all of this, we want to store two attributes. So store named attribute here, and it's just going to be a float, and we're going to call this x and this one y. and just take this factor value and plug it into both of these. So what we now then have, if we look at named attribute x, if I look at this, so the x I put this in the wrong places. Oh, sorry. So the y needs to be here, and there we go, and the x will be after this curved circle here. This is turning into a mess. That's fine, I guess. So now you can see that this is the y value and the x value is not connected, is like this. And then we can take this same store named attribute UV map and do a combine XYZ and take the x into the x and the y into y. And now you will see that there are some UV maps. Just one issue, it's kind of right at the edge where it goes back to normal, there will be this pinching. So if you don't like the way that looks, too bad. It doesn't, I don't know a solution to this other than UV wrapping it the correct way, but then that has the other problem of moving the UV maps. But this will hardly be noticeable unless you have some very prominent textures on this. So that's good enough for me, and we can see that it's working exactly as intended. That is all we need from geometry nodes, and it is time now to go and look at the armature and what we're going to do and how we're going to make the FK-IK system. So let's move this back to there. We don't need this anymore. And let's put it back, the 3D cursor. So very simple. We go to the top of the arm and add a armature single bone. Then we go to the elbow. Take this head, no actually that's the tail of the bone, and put it over here, and then extrude and put that at the end like so. And what we now need to do is go into the empties and get a, you could use many different things. I'm gonna use copy location. Select the armature and select the first bone for that one. And then select the two other empties, and we're just gonna copy this, copy to selected. And so the elbow, can just move it to the tail of the first bone, and the wrist we're gonna put it on the second bone and move it to the tail, so like that. So now if we pose this, you will see that it works normally. We're gonna need two more bones for this system. So the first one is the IK bone, and we're just gonna go Alt P and clear parent, and let's just move it forward like this. When you're doing this for real, remember to name your bones. It will make life easier for the animator who's going to use this, and that might be you. So name things in a way that anyone will understand what it's for. And we're extruding one more bone from the elbow, and we're gonna disconnect this bone, but we want it to still be parented to the arm, so that if I move the arm like that, it will stick to the bicep, but we can move it freely because we want, this is going to be the controller for this empty, so that we can bend the arm freely. To do this, we're just going to take this copy location and change this bone to this bone. Move it back. So now if I move this bone, ta-da, it's moving exactly as intended. Let's turn off that. So it's moving like this, and I can actually move it anywhere along the arm to make this animation. You can do the wave or anything you want, and you could actually make more of these points along the curve or the arm to make it sort of Adventure Time waves or whatever you want. So now the last thing we're going to do is get the IK stretch, and that also will be a constraint. So select this bone at the end, and I'm not going to touch on how much on the principles of IK/FK rigging. There are a million tutorials on YouTube how to do that, so check out any of them and they will explain the core principles and how to make it correctly. This is just how I'm doing it for this simple rig. If you want to make a more complex rig, you can just apply the principles of IK/FK rigging to this rig and it will work just fine. So this bone needs a constraint called inverse kinematics. Simple enough. And the target is the armature, and it is the IK bone. And you will see nothing has happened. We want to put the chain length to 2 in this case. So chain length of 1 is just itself. Chain length 2 is the next bone. And depending on how many bones you have in the arm, that value will vary. You can see that nothing is actually happening. It's just pointing at it. If I go like this, it will start bending, which is what we want, but we also want it to stretch, and there is a simple setting for that. So in the bone, you can go into the bone properties, and in inverse kinematics, there is this slider called IK stretch, and the moment I make it anything else than 0, it will just bloop, stretch. So I'm going to put this to 1. So now that bone is gonna be stretching, and this is the whole problem with rigging this. Normally if I would use this technique, it would actually be scaling the objects in every direction, and there are a bunch of settings that you can adjust how this works, but none of them work the way I wanted it to, and that's why we're doing it this way. And we also want the other one to stretch, but not as much, so we're going to put that to 0.5. So now you can see that it stretches a little bit, but not completely, and you can see the elbow is also moving along with that. And then if I move the elbow, you can see how this arm is going around, and that pretty much done. The only thing we want to do is we want to add that IK/FK slider to this bone. So in the bone properties, custom properties, new, and we're gonna call it IK/FK, default value of 0 and 0 to 1, and let's just make it a factor. Set it to library overridable, just because if you link this to a different scene, you can override the value and actually use it. So okay, default is 0. So what we then gonna do is we're gonna take this value and copy as new driver, and in this bone with the IK constraint, we can just paste that value in here. So now if I select this bone, I can slide the IKFK. So if it's at 0, this works just like an FK rig. I can move the arms freely, and then if I go IK, it will just slide into there, and it will like use this rotation to sort of blend in there, and you can create some cool animations using that. And you have this elbow controller to adjust where it bends and how it bends. And that is it. So now we have an arm that we can stretch, squash and stretch, bend and animate. And applying that technique to this rig here, we have everything working as intended. So we can bend the arm and we can stretch the arm as we desire. So I hope you found that useful, and I hope you learned something. If you want to learn more, then consider subscribing. And if you have ideas for something that I could teach you, something that I made or something that you want to learn, put it in the comments and I will see what I can do. But thank you so much for watching. Until next time.